In this machine learning class, we will see the partitioning method. There are two types of algorithms in partitioning method, k-means algorithm and k-mean-odds algorithm. And in this class, we will see the k-means algorithm in detail. And those are the things will come under 5th unit supervised learning. So in today's class, we will see the k-means, that is the centroid-based technique, and strength and weakness of k-means algorithm, and the stepwise k-means algorithm, and choosing the appropriate number of clusters, and elbow method, that is measure the homogeneity and heterogeneity. First, let us see the partitioning method. There are two important algorithms there in partitioning method. First one is k-means algorithm and second one is k-mean-odds algorithm. Here the k-means algorithm, this is the centroid of prototype which is identified for clustering. Okay, and the centroid is nothing but the mean of the group of points. For example, this is the group of data points. Okay, so these will be considered as a single cluster. Okay, and here for all the data points we need to identify, or we need to compute the mean of the value. So from the mean we need to find the distance between those 2 points. Okay, so based on mean value we construct the cluster, that is k-means algorithm. And next one is k-mean-odds algorithm. When come to k-mean-odds algorithm, it identifies the mean-odds which is most representative point of the group of points. That means, so in this group of data points, here we need to find out which data point is the most appropriate center point. Okay, here the difference between these two is the centroid does not correspond to actual data points. That is, this is centroid, isn't it? Mean algorithm. So mean algorithm, mean means the computed value. Mean means the computed value, but mean-odds is the actual data point. The actual data point which considered as a center of the cluster, right? First, let us see the k-means algorithm. So the k-means clustering algorithm is used to partition a set of objects into k clusters, right? In such a way that the sum of squared distance between the objects and their assigned cluster mean is minimized, right? So initially we are having a set of objects. So this is the set of objects before clustering, and n number of data points there in our data set, right? Now we need to partition those data points into k number of clusters, right? For example, if k equal to 4, that means all the data points will be assigned to any of the 4 clusters, right? Here k is user defined parameter that defines the number of clusters desired. For example, we can select randomly 4 point and we try to assign the nearby data into this particular cluster. Okay, so after performing the clustering algorithm, see all the data points will be assigned to the cluster 1, cluster 2, cluster 3 and cluster 4 like this. Okay, now the homogeneity and difference between the cluster. Homogeneity means the data points inside the cluster are similar to each other, isn't it? So this is homogeneity. And heterogeneity means the data points from different clusters are extremely different between each other. Okay, so this defines the efficiency of the clustering algorithm. And next, let us see the stepwise algorithms of k-means. Step 1, select k points in the data space and mark them as a initial centroid. Okay, here k is nothing but the number of clusters. So number of clusters. For example, number of clusters 4 means we need to mark 4 initial centroids. Initial centroids in the data points. Randomly select 4 values. And step 2, assign each point in the data space to the nearest centroid from the K clusters. Okay, so we will assign the nearest data point to this particular cluster. If it is here, then this will be assigned to here. If it is here, then this will be assigned here. So based on the data point, the data will be assigned to the nearest centroid, right? And step 3, measure the distance of each data point in the cluster from centroid. Okay, see, once we assign this particular data point into this cluster, then again we need to compute the centroid, that is mean value. Now the mean value will get changed, isn't it? So if we add the number of data point into cluster, in every addition the mean value will get changed. And step 4, calculate the sum of squared error to measure the quality of centroid, quality of clusters. Okay, so if it is outlier, we consider this as outlier. If it is assigned to this particular cluster, then error will occur. Okay, so we need to perform the sum of squared error, and this sum of squared error should be minimum. Okay, and step 5, identify new centroid of each cluster on the basis of distance between points. So for every iteration we need to compute the new centroid point. Okay, and repeat step 2 to step 5. So step 2 to step 5 until centroids do not change. Okay, this is important. Okay, and the loop ends, right? So what we are going to do here, we are having a set of data points and randomly we select any 4 points. For example, if we are having 4 number of clusters, and the nearest data point will assign to nearest centroid, that will construct as a new cluster. Okay, and once everything will be performed, then we need to compute the new mean value for each cluster. Okay, and the loop will be repeated until the center value, that is the mean value, do not change. A certain set of data points, we have to apply the k-means algorithm to find the clusters generated from the data set. The clusters generated from the data set. Let us take k equal to 4. So k-means means k equal to 4, that is 4 number of clusters we are having in our data set. At first step, we assign 4 random data points. See, 4 random data points we need to assign like this. Randomly we can select any 4 data points to the nearest centroid to create 4 clusters, right? And when come to second step, on the basis of distance of points from the corresponding centroid, the centroids are updated and points are reassigned to the updated centroids. Okay, so the nearby point will be assigned to this particular cluster, and once the data points included the cluster, then we need to compute the new centroid. Okay, so based on that, the data points will be assigned to the updated centroids. Okay, after 3 iterations, so this will be repeated. After 3 iterations, we found that the centroids are not moving. There is no scope of refinement. Okay, the centroids will be fixed in one place. That means there is no need of further iteration. That is, the clusters are constructed perfectly. That means. Okay, then the program will get terminated. Okay, this provide the most logical 4 groups or 4 clusters of the data set, where the homogeneity within the group of highest and the difference between the group is maximum. Homogeneity is highest and difference between the group is maximum, right? Choosing the appropriate number of clusters. Okay, that means before starting the k-means algorithm, it is important to know the data set and the correct number of cluster assumptions. So without this knowledge, if we start k-means algorithm, then we will not get the appropriate output, right? For example, suppose if we want to cluster the students of an university, then it is important to know the number of departments in the university. So if we know the number of departments, then we can cluster the students based on the department, isn't it? Otherwise, clustering the student is very difficult, right? And we'll take another example, that is, based on the business needs or resource limitations, the number of cluster requirement will get differed. Okay, so for example, suppose we are going to uh, create a movie, that is movie maker, and the cluster of the movies on the basis of two parameters, the combination of two parameters. First one is budget of the movie. The budget may be high budget or low budget. Okay, based on the budget of movie, there are two clusters. And casting of the movie, that is star or non-star. Okay, so based on the casting, there are two clusters. So totally there are four possible combinations. Okay, that is high budget, low budget, and star, non-star. Okay, accordingly 4 1 2 3 4 1 2. Okay, star with high budget, star with low budget, non-star with high budget, non-star with low budget. So there are four number of clusters there. So based on the requirement also, the number of clusters will get changed, right? For choosing the number of clusters, we can use this thumb rule. Thumb rule means k equal to root of n by 2. Okay, we know what is k. K is number of clusters. Number of clusters, isn't it? Isn't it? Here, n is the number of data set. N is number of data set. So, k is defined based on the square root of n by 2. Square root of n by 2, right? But this thumb rule does not work for large data set. So the thumb rule is applicable only for small data set. Okay, what is thumb rule? K equal to root of n by 2. Here k is number of clusters and n is the data set, right? And there are several statistical methods to arrive the suitable number of clusters. Okay, by using some other method also, we can identify the number of clusters, that is suitable number of clusters for the given data set, right? And next let us see the elbow method, which is used to measure the homogeneity and heterogeneity within the cluster. Okay, and various values of k. So this is the k value. Here we are having different k value. So accordingly the point is determined, right? And the elbow point used to determine the appropriate number of clusters. So how many k are there, that much clusters will be there in the data set, right? The homogeneity will increase or the heterogeneity will decrease. So this is homogeneity. Homogeneity will get increased and heterogeneity will get decreased. Negative slope. Heterogeneity will get decreased. Okay, so when increasing, after certain point, then the increase will get reduced. Okay, see, from up to here the increase will be very large. After that the increment will get reduced. Okay, reduce with the increase in homogeneity. When come to heterogeneity, it decreased up to certain point. After this the decrement will get reduced, isn't it? So this is called as heterogeneity. So in this diagram, after a certain point, the increase in homogeneity will get reduced. See, so the increase in homogeneity, increase value will get reduced. Okay, so this much increase here from this cluster to this cluster, but here the size will get very much reduced. Okay, so this particular point is called as elbow point. So see, this will go like this. Okay, when decrement, this will come like this. Okay, and there are large number of algorithms to calculate the homogeneity and heterogeneity of the clusters. Okay, so already many other algorithms are also there to find out the elbow point, that is homogeneity and heterogeneity of the cluster. Choosing the initial centroids. Okay, So already we have seen in k-mean algorithm, we need to understand how many number of clusters there for the given data set, isn't it? Suppose if there are 4 number of clusters, then we need to initialize 4 number of centroids properly. For example, for 4 number of clusters, we need to randomly select 4 different centroids, isn't it? And choose the random points in the data space on the basis of number of cluster requirement. Right? If it is 4, then we need to select 4 different centroids and refine the points as move into iteration. So every iteration, the center point will get changed. So that means if we increase the number of data points, then immediately we need to compute the new centroid. Okay, so according to the data point, the centroid will get changed. But this leads to higher squared error in the final clustering, right? Recomputing the cluster centroid. Okay, so the data points from each other within the cluster is measured to minimize the distance to its centroid. That is, see if there is new data point entered here into the cluster, and for example, this is the centroid of this cluster, and this distance should be measured, and accordingly the centroid will be reassigned. For this we can use the Euclidean distance. Okay, so the Euclidean distance between two data points is measured. The distance between x comma y, which is equal to square root of summation of I equal to 1 to n xi minus yi whole square. Okay, so this is the Euclidean distance formula. By using this, the distance between the data points and its nearest centroid is calculated, and this will be calculated for every iteration. Okay, and if the centroid is not changed for the few iteration, then we can stop the algorithm, right? And that is the exact centroid for this particular cluster, that means. And next, we need to measure the quality of clustering by using SSE. SSE means sum of squared error. Okay, so the formula for sum of squared error is sum of I equal to 1 to k and sum of x belongs to ci. Okay, dist of ci comma x whole square. Here capital C is nothing but the cluster. Okay, and small c is nothing but the centroid of this cluster, centroid of the cluster, right? So k is nothing but the number of clusters, right? Suppose if you are having 3 number of cluster, first it will take this particular cluster ci equal to 1, and in this centroid it will compute the x value. For example, uh, we are having 5 points, means 5x will be there. For all those things we need to compute the centroid value. Okay, so with respect to the centroid of cluster C and the data points x in the cluster, we need to compute the center point, that is the mean, and the summation of each distance over all the k clusters given the total sum of squared error. Okay, all the squared error will be computed, then this is called as sum of squared error. Okay, and the sum of squared error should be very minimum, then only our solution will be the better solution, right? The limitation of sum of squared error is, suppose if there are outliers in our data set, then the sum of squared error can misrepresent the mean value of the cluster, right? And let us take one example here. Figure 1, this is the figure 1 before clustering. Okay, and the required number of cluster k equal to 4. Okay, so what we have to do, we have to randomly select 4 cluster centroids. So from this point we randomly select 4 cluster centroids. Okay, so the star represent the that is center point of this cluster. Randomly select any point. And next, partition the data set into 4 segments based on centroids. Okay, so these are the 4 centroids we are having. Based on the centroids, the clusters will be partitioned. See, the clusters will be partitioned like this. Okay, and this particular diagram is called as Voronoi diagram. Okay, which creates boundaries of the clusters. Voronoi diagram, what is the purpose of Voronoi diagram? That will create the boundaries of clusters. Now how many clusters we are having? 4 clusters. Okay, so this is C1 cluster 1, C2, C3 and C4. 4 clusters are there, and those are created by the vertices of clusters, dashed lines. Okay, and the points with maximal distance from center of the clusters. See, from the center of cluster, maximum points will be arrived. And now it is easy to understand the areas covered by each cluster. Okay, and data points within the cluster. Suppose if the new data point comes here, then obviously that will goes to cluster C1. Suppose another data points comes in this place, then that will goes to cluster 4, isn't it? The next step is to compute the SSE, that is sum of squared error of the cluster, and update the position of centroids. So based on the SSE, we need to update the centroid position for each clusters, right? And accordingly, the cluster boundaries are redefined based on the new centroids. Okay, so based on the centroid, the cluster boundaries will also get changed. So now the data points from one cluster will move to another cluster. Okay, and the K-means algorithm continues with update of centroid according to the new cluster. Okay, and the reassignment of the points will get reassigned from one cluster to another cluster until no more data points are changed due to the centroid shift. Okay, so at this point the algorithm stops. And this figure represents the final clustering of dataset. Okay, so after this point there is no movement of data points as well as no movement of centroids. And the complexity of K-means algorithm is order of nkt, where n is total number of data points in the data set and capital K is number of clusters and t is nothing but the iterations, and K and t are kept much smaller than n. Okay, that means the total number of data points should be very high and the cluster and number of iterations should be very small. Then this K-means algorithm will be very efficient, right? Next, let us see the strength and weakness of K-means algorithm. First one is strength. Here, the main use of K-means algorithm is to identify the clusters, and it is very simple and very less complexity. Okay, and second one is the algorithm is very flexible and it can be adjusted for most scenarios, and the performance and efficiency are very high. So these are the strength. When come to weakness, it involves an element of random chance of selecting the clusters, and the starting point of guessing the number of natural clusters, it requires some experience. That is, only the experienced people can identify the number of clusters naturally, so that we will get the efficient outcome. Otherwise, the outcome will get failed. So far we have seen the partitioning method and the K-mean clustering algorithm from 5th unit unsupervised learning. Here we have seen what is partitioning method and what is K-means algorithm, that is, it is otherwise called as a centroid based technique, and choosing appropriate number of clusters, and the elbow method to measure the homogeneity and heterogeneity, and finally we have seen the strength and weakness of K-means algorithm. And the next class we will see the K-metered algorithm from partitioning method. Thank you.